Okay, hi class. So I'm just going to give you some help with your homework in case some of you, say some of you might not quite have understood what you have to do. But I do want to say this: conceptual understanding, understanding exactly what's going on, and being able to do a procedure are two different things. And despite what everyone says to you about understanding being so important, the truth is you can learn how to do something and subsequently learn why it works. So aim to learn how to do this. Um, so we'll wipe out the example that's on the board and we'll just start one of your homework questions. Okay, so the first question is x squared. The first function is defined by a mathematical rule and a domain. A mathematical rule and a domain. Okay? So the rule looks like, in notation, f of x equals x squared minus 6x plus 13. And we're saying that it's defined in the domain from between 3 and 8. Okay? Now let me recall that what we did today is adding up odd numbers. We noticed that the square numbers, the x squared numbers, evaluated as integers 1, 0, 1, 2, 3, 4, etc. come out with at 0, at 1, at 4, at 9. Okay? It's looking kind of backwards to me on the video, but hopefully you see it straight. 16, etc., 25, etc. Okay? Now the pattern that's going on, and I'll cut away the second half of x squared because most people don't really think about it. The pattern that's going on as you square x's is a curved up. It's half a quadratic, it's half a parabola. Indeed, if you allow the negative numbers, it's a full parabola. Parabola is just the word we get for one of these things. Okay? Now, the result of adding to the x squared that we started with a minus 6x and a plus 13. The easiest thing to say is that the plus 13 just lifts it all up. So in other words, when you put 0 in, instead of getting out 0, you'll get out 13. You'll get out 14. You'll just keep adding 13 to all those numbers. Okay? So this will be the y-axis then, up the middle. But then the result of the minus 6 is to move it to the right by 3. Okay? And indeed, it tells us that it's going to do that, but it's also going to cut here at 13. So it's going to have a slope when it goes through. Every curve, if you look at it at a small little place, looks like it's straight. And a straight line has a slope, steepness. Okay, so this seems to have a steepness of negative 6, meaning for every 1 forward you go down 6. But despite all the messy, complicated stuff I told you there about minus 6x and 13, all you're doing is translating, moving this in some direction. But the pattern, once we find the vertex, is the same. Out 1, up 1. Out another 1, up 3. Well, from here, up 3. Out 1, up 5. That's the pattern. So our main goal, at the very beginning, the first thing we're trying to do is find this sweet spot, this vertex of this parabola. If we know that, everything else falls into place really quickly. The easy way to get it is to find the x value first. It's easy to do. Half of that, now you can say change the sign in half, or you can say half and change the sign. Half and change the sign. It's 3. So 3 is the middle. In other words, if you look at the xy axis, out 3 is going to hold my parabola in a smooth central way, symmetrically, wherever it starts is another ballgame. Okay, but I know it's occurring at 3. So I can substitute 3 into the original function. And I can tell you right now, the bottom of this, the vertex is 3f of 3. Okay, 3f of 3, but calculate f of 3. F of 3, keep it in his jacket, equals 3 squared minus 6 times 3 plus 13. Yep, I was afraid I didn't put a big enough number here, but I did. I put it plenty big. 9 minus 18 plus 30. You can do this any way you want. But that looks like plus 4, does it? Looks like 4. Which means this is actually 3, 4. Okay, so I hope now you know we found this 3, 4 as being really important. But this is a multi-step problem. This is not when you just do something and you're done. So now the ordeal, or the procedure continues. 3, 4 is easy to remember. So the procedure continues. So I know now the vertex, which is a point, is equal to the point 3, 4. Let's move into a table. We will typically put the x, the independent variable, the x variable along here, and the f of x, the tabulated values that we get for it along here. Now I'm going one-sided here because I'm keeping it easy. So we're going 3 as an output, the input of 3 is input, is output. So this is going to go 4, 5, 6, 7, up to 7. Now almost as simple as the line, but not quite. Start by adding 1. You're adding 1 because that's 1. If that was 2x squared, you'd be adding 2. And then instead of adding 3, you'd be adding 6, you'd be adding doubles all the way along. And more about that some other time. Not yet. You're adding 1. You're adding 3, next odd number. You're adding 5. And you're adding 7. Okay, so we've calculated the vertex. We've tabulated the values within the domain at lattice points, at the integer values. Skip the middle. Of course, there's a smoothness in between, but we don't care. Now we're going to graph it. Okay. There's the beginning of a graph. We're doing great. 3, 4, out 3, up 4. That's where that is. Forget the scale. The scale comes later. Don't worry about you're not having graph paper. This half of a quadratic is a curve up. Notice start off flat and move along up. So I'm going to say straight off the top, this is 7, 20. This is 3, 4. And then just take your pick in between. If that's 3 and that's 7, you know, don't kill yourself. Of course you could go 4, 5, 6, and 7. You might have picked a different one, but I'll pick 6, 3, 4, 5, 6. So I'd say 6 gets 13. Now, an extra challenge is, of course, just to put that into your calculator and start at 3 and end at 8. And you know how your calculator will spit out all the values at you. Don't have a calculator with me. Oh, bold. I should have it in my pocket, but I don't. Okay, but that'll happen. That just happens like that. And that's the end of your question. Now, big question is, will I just do all your homework for you? Well, you shouldn't have to look at it. You should work out the second one, just in case. And I want you coming in with your homework. I'll give you the second one as well. That's bad. No, I shouldn't do that. But here it goes anyway. So the second question is over here. You see this? Maybe you can make it out, maybe you can't. But I'll drop it in up here instead. No, I won't. Let's move the... Let's move... Oh, by the way, if you were very quiet, you'd all be there, sitting there. And it'd be so great I turn around and the whole class would be there. Just look at it. You're not, it's just empty. Okay, and I did wipe down your desks, of course, just in case you're questioning your editor. Okay. And we're up here now. Shine on the board, we'll try to work our way around that. Okay, so we're doing this question. We just did that one. And we will transcribe it up. Scribe is to write. Trans is to just rewrite, because I want that space at the bottom. So I'll call it f of x equals x squared minus 8x plus 19. Just copy it out again. It's good to be able to transcribe it whenever you like, especially from one page to the other when you're working. 4 is less than or equal to x, which is less than or equal to 9. Okay, so the procedure has now become a kind of a standardized procedure that we're going to go through. It involves find the x value of the vertex, substitute that to find the y value of the vertex. Use that as the first couple of a table of values, going 1, 1, 1 up 3, 1 up 5. As you go through the table, sketch it, taking the two endpoints of the domain, two endpoints of the line of the graph of the section of the function. By the way, it is the whole function because the domain keeps it restricted function. And then put one of the points in between, just for fun. So, and of course, by the way I make up the domain, it kind of gives it away because I told you 4 is the beginning. But minus 8 turns into plus 8 and half is 4. So I need f of 4. And again, I think I told you something today. Was it me? And it was what Einstein said, is everything should be made as simple as possible, but no simpler. So I could break this down further and further, but you need to at some stage think this is the level. So I hope the reason I'm saying that is this explanation should, if I try to make it more simple, you're probably not thinking at a high enough level. So I'd say if you're finding it hard, just pause more often. Work it out. Okay. So I could go off and if somebody said, can you make a PowerPoint, but I think this method here is best way to learn it. So f of 4, I'm putting 4 in. Why? Because 4 is the value of the x. It's the input value that gives me the output value that I'm interested in, the vertex value. So f of 4 goes in, my function is here. So that's right, f of x equals x squared negative 8x plus 19 here. So I'm going to have 4 squared minus 8 times 4 plus 19. So a bit of calculation going on here. You could use a calculator if you want to. You can use a calculator for everything here and you won't have to do any of this, but that's not progress, because I want you to understand how they behave. And the calculator will calculate it for you, but it won't teach you and tell you how they behave, how quadratics behave. I'm going to drop the bracket, but that's okay. Okay, I have 16 and 19 is almost double 16, but it's 3 bigger. And that 3 bigger is the lingering bit, so it's 3. Okay, because the 2 16s would have cancelled with -32. So this time actually it's 4, 3. That time it was 3, 4. This time it's 4, 3. Can't argue, I'm making them nice questions. 4, 3. So the vertex equals 4, 3. Okay. Inputs, outputs. Now this is where we have a magic recipe. It's called iterative. Start in one place, you know you can go to the next step. You iterate through. And it maybe a little bit like a chess, but not quite. Out 1, up 1, then out 1, up more, then out 1, up more again, then out 1, up more again. If this is 1, this is 3, this is 5, this is 7. That might help you visually. Say, oh yeah, going up those bigger and bigger steps make it curve up exactly the way it should. 4 is the first value. 3 is the second value. We need that as a launch pad. 4 turns to 5, turns to 6, turns to 7, turns to 8, turns to 9. And that's where I said to stop. 3 goes up 1 to 4. Your first baby step. Now up 3. Now up 5. Now up 7. And brace yourself. Up 9. Still in single digits now, not that bad. 19 and 9 is 28. Okay. Now plot. How much space have I got? Well. Now, here we go. So, 4, 3 is my seed that's going to grow. Think of it as a seed growing a plant. Lovely, lovely plant. Except this growth will be quadratic. Okay, so we're at 4, 3. It's our first point. The x and the y axis are down here somewhere. Y should have an arrow pointing upwards. Should it point upwards or both ways? Well, it goes in both directions. Except in our domain here it doesn't, but the x goes in both directions. It's allowed to go both ways. 4, 3. That's the lower point. That's the end point of our graph. You know, you talk about end points of a line segment. Well, essentially this graph is a curved path, but it still has endpoints. Okay, and you're best off drawing it first, then putting in the label. So now I'll tell you this is worth 4. Put in this 928. Now let's call that 9 and let the scale sort itself out in between. And pick any random point in between. Let's go with 6, 7. 6 is there, and you know what we said about Nova's coming along with a measuring tape to us. After all, it's a pandemic and we don't have our crap paper handy. Okay, so out 6, up 7. And by putting that coordinate on it, you're telling us, you're saying that's where it is. Now look, let's have a bit of fun and put the rest of them in. 5 gets 4. 7 gets 12. And 8 gets 19. So these are not magic numbers that your calculator spat out at you after a terrible amount of calculation. They're following a beautiful pattern, the pattern of quadratic pattern of monic, monic meaning it's an x squared. So it has the exact same shape as an x squared curve. That's it. That's your help with homework. In fact, that's your homework done for you. So just go through this line by line and copy it. But if you have a true productive disposition, then you'd say, well, I got all that help with the homework and I'll do an extra one for fun. So that's the real challenge. You don't have to, but I'll throw up an extra one for you in case you did all of them and you want the extra challenge of not of having a question that you need to kind of self-verify, which you can do in a calculator. So here we go. F of x, or let's switch it around. Let's go with g of x. So g of x equals x squared. That's a given. That's what type of question we're doing today. Okay, x squared. Now I need an even number. I always started off with negative so that I stayed in the first quadratic, and first quadrant, and we're going to do that today. First quadrant means this quadrant here. So my entire quadratic lived in there. And then being a minus an even number, let's go to 10x. Now I know that 5 5s is 25. You see this 5 5s is 25. If I put 5 there, I get 25, and then I get minus 50. So this is a very quick way of knowing how big this number needs to be in order to stop this being negative. But this number has to be bigger than 25 in order to stay in the first quadrant. So if I make it 26, it's up 1. Make it up 3, 28, etc. Let's make it 29, make it up 4. I mean relatively up 4. So it's going to be 5, 9. It's going to be the vertex. I'm pausing because it does mean, if you follow what I did there, there's a very quick way of getting to 9. You have to mathematically think along with me here now. It's this. To get that second value, you don't have to put 5 in to this. You can do it another way. You can get the number 5 like you always do. Half of this, change the sign. And anyway, you're squaring, so it doesn't matter whether you change the sign or not. But 5 is the special number for this problem. 5 fives is 25. Oh, yeah, I made a mistake actually. Okay, let's make that 34. 5 fives is 25. Take 25 away from that and you get 9. And that's what goes there. So example over here, that was 13. That was 13. 3 threes is 9. 9 away from 13 was 4. Okay, all these hidden gems inside the maths. Okay, it's a very beautiful thing that quadratic is doing something in a very standardized way. It's not very complicated. So back here, that's your question, and your extra question here is x squared minus 10x plus 34, but I have to give you a domain. But you could work out the domain for me. You say, well, I'm going to start with 5 anyway. And my domain will run up to 10 or 11, or because I'm going to make you do proper work now, we'll run it up to 12. Crocodile opening to the right. Crocodile with teeth at the bottom, because we want to include the endpoints. Between 5 and 12, x squared minus 10x plus 34. That's it. Enjoy your homework. Computer room tomorrow. I have to check whether we can go straight there, whether I meet you in the room. Okay.